Hello, this is Mrs. Ross, and this is Lesson 6, Factors and Divisibility. These are the starred problems in the practice set, and you'll find them starting on page 42 of your Saxon Course 2 textbook. Let's go ahead and get started. Okay, so number 2 says, list all common factors of 30 and 40. So first thing I have to do is list the factors of 30 and 40. The numbers that multiply to make 30 and 40. So 1 and 30, 1 times 30, 2 and 15, 3 and 10, 4, 5 and 6. I think that's it. All right, and then for 40, we're going to do the same thing. You'll see that I start with 1 and whatever the number is, and I kind of fill in the blanks in between. 2 and 20. 3 doesn't go into it. 4 and 10. 5 and 8. Okay, so these are all the, these are all the factors of 30 and 40. We need to figure out what they have in common. So let's see, they have 1 and 2 and 5, 10. So we have 1, 2, 5, and 10 as common factors of 30 and 40. And B asks what the greatest common factor is. So that's the largest factor they have in common, which is 10. Number 3 says use braces, these are the chocolate chips, and ellipsis and digits to illustrate a set or group of negative odd numbers. So we have -1 is the first negative odd number, -3, -5, and it goes on and on and on that direction. So I'll put my chocolate chip here, my other chocolate chip there, we're good to go. Number 4, use digits to write 407,006,962. So I need millions. This is my millions. This is going to be my thousands. And this is going to be my hundreds. 407 million is going to look like this. 6,962. And that's my number. Number 5. List the whole numbers from 1 to 10 that are divisors of 12,300. And for our reference, I've put our little divisibility chart here. This chart is in your lesson 6 if you need to refer back to it. So let's go through it. It ends in 0, so 2 is going to work. The last 2 digits are 0, so 4 is going to work. If the last 3 digits can be divided by 800, so let's check that one out. 8 times 3 is 24, 60, that's not going to work. So 8's not going to work. 5 and 10, wait, are they single? No, it says whole numbers, so we're good. 5 and 10. Check. 3 if the sum of the digits. So we have 1 plus 2 plus 3 plus 0 plus 0. And that gives us 6. This is my sum. That is divisible by 3, so that'll check out. I have 2 and 3, so it's divisible by 6. However, 6 is not divisible by 9. So my answer is 2, 4, 5, 10, 3, 6. I could probably write that in order and make it look beautiful, but number 6. Let me change colors here. Replace the circle with the proper comparison symbol. That's going to be a greater than, a less than, or an equal symbol. Then write the comparison as a complete sentence using words to write the numbers. So I have -7 is greater than, equal to, or less than -11. And I know that on the number line, the further left it is, the less it is, right? So I have -1, 2, 3, 4, 5. So -7 is going to be here, and -11 is going to be over here. So -11 is less than -7. So our monster is going to eat the -7. And to write it out, it would be -7 is greater than -11, if I can spell 11 right. Okay, let's see what else we got. Number 7. The number 3, 4, 5, 6 is divisible by what single digit numbers? So again, we're going to use our test for divisibility. It's divisible by 2. because it ends in 6, which is an even number. Let's see, 56. Does 4 go into 56? I don't think. Yeah, it does. Okay, so 4 works. 8, so 8 would have to go into 456. So 8 times 5 is 40. 8 times 6 is 48. So this is going to be 40. Okay, yeah, that works too. Okay. Not 5, not 10. 3, if the sum of the digits, so 3, 4, 5, 6. So 3 plus 4 is 7, plus 5 is 12, plus 16 is 18, and that is divisible by 3. So that's going to go. 6 if it's divisible by 2 and 3, so that works. And then divisible by 9, yes, the sum is divisible by 9. So those are our numbers that they are divisible by. Let me change my colors. Number 8 is not starred, but I'm going to go ahead and show it anyway, because I probably won't require you to do it since it's on the number line. So we start at 0, and we go to 2, and then it's subtracting 5. So subtraction goes left. So we have 1, 2, 3, 4, 5. So my answer is -3. Write 6400 in expanded notation. So this means we're going to be using our place value. So I have 6 times, and the 6 is in the thousands place. And then 4 times, and the 4 is in the hundreds place, and that's my answer. Okay, find the value of each variable, number 10. So I have x plus $4.60 is $10. Since this is an addition problem, I'm going to do the opposite. Remember, addition and multiplication, should have it's the same every time. So my x comes down, these two cancel out, my equals comes down, and let's see, 10, I get $5.40. Okay. Now 11's a little bit trickier because it's got a subtraction. We know that if it's in the first place, we're going to add, and if the variable's in the second place, we're going to subtract. So it's in the first one, so we're going to go ahead and add this. What we do to one side of the equals, we have to do to the other side of the equals. So my p comes down, that cancels, my equals comes down, and I'm kind of running into my other problem, but here we go. I get 8,350. All right, more of these unknown problems, and let me just tell you that these problems do not go away. They actually just get more complicated. So it'd be good to get a good handle on these within the next couple of weeks. So we have a multiplication problem here. Every time we see something divided by something, we're going to divide. We're going to do the opposite. So 8 times z is $50. So I'm going to divide both sides by 8. I get z is equal to $50 divided by 8, which I'm going to plug into my calculator. And I get $6.25. So let's put the dollars there. Okay. And I'm going to change colors here. So 1426 minus k is equal to 87. You see we have our variable in the second place, which means we're going to subtract. Okay. Just kind of a rule that you need to have. If you want to put that in the back of your binder, you're welcome to do so. And I get k is equal to this. Okay, then we have some division stuff coming up here. So when my variable is in the bottom, I'm going to divide. And when my variable is in the top, I'm going to multiply to get my answer. So here, 45 goes into 990. Let me check my calculator. 22 times. So p is equal to 22. And then here I have z over 8 is equal to 32. I'm going to multiply both sides by 8. So my 8's cancel here. My z comes down. My equals comes down. And I have to do 32 times 8, which is 256. All right, let's see what's next. All right, last two problems. 29a says name the property illustrated by the following equation. It says x times 5 is equal to 5 times x. So this is all about order, and that means it's the commutative property, and we're multiplying. Okay, because we changed the order. The 5 was second, and then it became first. In your own words, explain the meaning of this property. That order doesn't matter with multiplication. Okay, list the properties used on number 30 in the first three steps to identify the expression or simplify the expression here. So that's our given expression. And what I do from here to here is I change the parentheses. So that's the associative property of, and we're multiplying, so of multiplication. And then from here to here, I change the order. The 7 and the 5 swap places. So that's the commutative property of multiplication. And then from here to here, I change the parentheses again. So that's again the associative property of multiplication. All right, that's the end of our starred problems. If you have any questions, please let me know. Have a great day.